Physics. Physics, 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 physics,
We are investigating horizontal circular motion. The variables involved in circular motion are the mass that is spinning in a circle, the radius of its motion, its speed or velocity, the force causing the motion. The formula is that the sum of the forces, or the circular force, is equal to the mass multiplied by the velocity squared divided by the radius. We start by choosing a mass. We used rubber bungs from the chemistry lab. This was spun in a circle with a measured radius. A set of slotted masses hung below the apparatus. These provide the tension in the fishing line to cause the mass to move in a circle. The time for 10 revolutions is measured so that the period for one revolution can be determined. The speed of the mass is the circumference divided by the period, 2 pi r over t. A graph of force versus velocity can be recorded for various masses. Excel was now used to draw a graph of force versus velocity squared. If this graph is linear and passes through the origin, then we can show that the force is directly proportional to the velocity squared. In a similar way, a graph of force versus velocity can be recorded for various radii. To show that force is proportional to mass, we need to keep the velocity constant. We did this by drawing a vertical line on the force versus velocity graph. We can then mark off the force and mass measurements from this graph and then plot a graph of force versus mass. If this graph is linear, then we can say that force is directly proportional to mass. In a similar way, a graph of force versus velocity can be recorded for various radii. To show that force is inversely proportional to radii, we need to keep the velocity constant. We did this by drawing a vertical line on the force versus velocity graph. We can then mark off the force and radius measurements from this graph and then plot a graph of force versus radius. This graph looks hyperbolic, so if we plot force versus the reciprocal of radius, and this is linear and passes through the origin, then we can say that force is inversely proportional to radius. In conclusion, we have shown that force is directly proportional to the velocity squared. Force is also directly proportional to the mass, and force is inversely proportional to the radius. Overall, F equals mv squared over r.